Okay guys, let's pick up where we left off in 2.4. It's time to take our chain rule and combine it with our previous product quotient rules, power rules, all of the rules, and then try to simplify as much as we can when solving problems. Let's talk about f of x equals x squared times the square root of 1 minus x squared, finding the derivative. This is product rule. So one thing that we know is that when we have two things multiplied together, to use the product rule, it's 1 times the derivative of the other plus the other times the derivative of the first. So the easier one for us to take the derivative of right now will be the x squared. So it'll be 2x times my original square root of 1 minus x squared plus my x squared times the derivative of the square root of 1 minus x squared. And this is going to require us to do the chain rule. This is really 1 minus x squared to the 1/2, and the derivative of that is 1/2 times 1 minus x squared to the negative 1/2 times the derivative of the inside, which is negative 2x. So in total, that makes the negative 2 and 2 make negative 1. That'd be negative x times 1 minus x squared to the negative 1/2, which will go here. Now if we clean this up, this is now 2x times 1 minus x squared to the 1/2. I'm going to use fractional powers for now. Minus x cubed times 1 minus x squared to the negative 1/2. Now there's a strategy we can use to factor out algebra that's kind of unusual from what you've done in the past. Here we can factor out a negative exponent because we know it's going to the denominator, which will allow us to actually kind of rationalize both of these 1 minus x squareds. And that way, what I'm going to do is these both share an x, but they also share a 1 minus x squared to the negative 1/2. Everything technically has a negative 1 minus x squared to the negative 1/2 because you can pull out something that by adding more to the numerator. This is the equivalent kind of getting a common denominator between both terms. And what that would lead is 2, and then look at this. When I take away 1 minus x squared to the negative 1/2, I'm really adding a 1/2 power to each of these. So this becomes just 1 minus x squared to the first power. Here we took an x out, so we've got minus x squared. And I took the whole 1 minus x squared to the negative 1/2 power, so I'm left kind of right here. Now, when I distribute here, this will be 2 minus 2x squared minus another x squared, which is really going to be 2 minus 3x squared. And if I were simplifying this, I would put my x and my 2 minus 3x squared in the numerator. A 1 minus x squared to the negative 1/2 is really the square root of 1 minus x squared in the denominator. And this is about as simplified as I can get this derivative. And hopefully I don't have to take another one. I could, of course, multiply the x in, but sometimes having the x outside so we can make sure nothing cancels is more useful. But yes, it's entirely possible, or if we're using chain rule to take more derivatives. Oh, what about with quotient rule? Quotient rule, again, can require chain rule, and we have to be careful. Let's look at B. So remember, the derivative for quotient rule is the denominator, which I'm going to call x squared plus 4 to the 1/3, times the derivative of the numerator, which is 1, minus the numerator times the derivative of the denominator. So off here to the side, we've got x squared plus 4 to the 1/3. The derivative of that is 1/3 times x squared plus 4 to the negative 2/3 times the derivative of our inside, which is 2x. So I will write that over here as 2x over 3 times x squared plus 4 to the negative 2/3, all divided by x squared plus 4 to the 1/3, which is actually now squared, our denominator squared. And from here, again, it's going to be a cleaning up aspect. This is really x squared plus 4 to the 1/3. This is minus 2x squared over 3 times x squared plus 4 to the negative 2/3 over x squared plus 4 to the 2/3. Now, where is the factoring going to come into play here? Kind of in the numerator. If I factor out an x squared plus 4 to the negative 2/3, what I'm left with in the numerator is I'm subtracting negative 2/3, so I'm adding 2/3. This becomes x squared plus 4 to the first power minus 2/3 x squared, all over x squared plus 4 to the 2/3 power. I can clean up the inside here. X squared plus 4 minus 2/3 x squared. I could have factored the 3 out as well. Should be 1/3 x squared plus 4. And I can actually roll this negative exponent into my denominator here. Moving it to the denominator would make it a positive 2/3, but if I have 2x squared plus 4s to the positive 2/3, that in total is x squared plus 4 to the 4/3. We can see how maybe this would be easier. We can move the 3 down and multiply by 3 as well. Another way we can do this is call this x squared plus 12 over 3 times x squared plus 4 to the 4/3. But either way, it demonstrates the power of the chain rule, but also the complexity that comes along with it. And lastly, even though we've seen it, they make an extra section about applying the chain rule to trig functions. And if we look at the trig functions and we want to apply the chain rule, it's the same kind of idea. The derivative of sine of 2x, for example, is cosine of 2x times the derivative of my inside function 2x, which is 2. So this is 2 cosine 2x. Even if there's a fraction on the inside, it works the same. My derivative of cosine is negative sine. I leave the inside alone, but I have to multiply by the derivative of the inside, which in this case, the derivative is 1/3. So this would be negative 1/3 times the sine of 1/3 x plus 2. And sometimes you can have multiple chains to deal with, even in trig functions. So again, tangent squared of 3x squared plus 1 is really the tangent of 3x squared plus 1 squared. And if we go outside in, the 2 comes down first. 2 times the tangent of 3x squared plus 1 times the derivative of my inside. The derivative of tangent of 3x squared plus 1 is secant squared of 3x squared plus 1 times the derivative inside my tangent, which is the derivative of 3x squared plus 1, which is 6x. So in total, this derivative is, I'm going to take the 2 times 3, 6x, 12x times the tangent of 3x squared plus 1 times the secant squared of 3x squared plus 1. So as you can see, the chain rule can get pretty complicated, but as long as you work outside in, you can get to the right thing. Below here is a summary kind of all of the rules we've learned in Chapter 2 so far. We'll learn one more rule in 2.5, but it's really kind of like a different way of thinking about it. These are the primary rules you're going to use for almost all of your derivatives. So excepting, and then 2.5 is, like I said, a rule that's looking about things in a different way, and 2.6 is going to be word problem applications of said rules. And that is all for 2.4.